Hello everyone, and welcome to another GIS tutorial video. And in this video, I want to begin our discussion talking about lines. And in specific, I want to discuss sort of the most common way that you're going to see a line expressed in an equation. And that is called the slope-intercept equation. Right, the slope-intercept equation. And so the slope-intercept equation, in case you're not at all familiar with it, is this equation y equals mx plus b. Y equals mx plus b. And what this equation does is it equates for any given x, it equates it to its comparable y. And what do I mean when I say it relates the x to the y? Well, let's go ahead and just really quickly sketch out a line here. So we'll have 0, 1, 2, 3, 0, 1, 2, 3. And let's make it so that it passes through roughly the point 2, 1. So let's look at this point right here. This point's 2, 1. So what the slope-intercept equation does is it relates an x to a y. So if I were to go up to 2, right, if I were to go up to 2 and I were to go over, right, what value do I get on the y-axis, right? That is what this equation, which represents this line, is telling you. It's saying, given an x, what y would I end up with? And there's two pieces here that aren't, so x and y are sort of any number we can think of. But there's two pieces here that are traditionally given as constants. And we have the m and we have the b. So m is often referred to as the slope of the line. Right. And so the slope of the line basically, again, we've talked kind of about slope before. You can see that as, as change in rise over change in run. You can see it sometimes called rise over run. Sometimes you'll see it as delta y over delta x. But right, all this slope is getting at is how does y change when you change x? Right. So again, looking at our little example here, right, when we go from x equals 1 to x equals 2, how does our y value change? So in this example, right, when y is equal to 1, right, x is equal to approximately 0.5, right, approximately 0.5. When we change x to 2, right, we go up, we hit the line, and we go over, and we get a value of y equals to 1. So the slope here, right, would be this change, right, would be this change in y over this change in x, right? And we're going to more formally talk about slope in another video. But for now, just keep in mind here that this m in this slope-intercept equation is the slope of the line, and that relates to how y changes when you change x, because the whole point of this slope-intercept equation is to relate any given x to its corresponding y. So that's the m. Well, what about this b? Right, b is what's called the y-intercept, or sometimes you'll see it called the intercept. Right, the intercept of the line. And the intercept of the line, right? This is basically saying, where does the line, this is basically where does the line cross the y-axis, right? Where does this line cross the y-axis? Or put another way, what is y when x is 0, right? What is y when x is 0? So I think the best way to examine this is to actually draw a line and go through some examples. So what I'm going to do is I'm going to actually, in the next video, I'm going to go through some examples of actual equations, not this sort of generic thing we have here, but actually use some values for m and b and walk through what those mean. So hopefully this made sense. I know there's not a whole lot of content in this video, but hopefully you understand what the slope-intercept equation looks like, what it means when we have the MB slope, and what it means when we say B is the intercept. And so just to sort of wrap this up with a nice little bow on it, right? We call it the slope-intercept equation because the two terms involved are the M, which is the slope, and the B, which is the intercept. So that's why it's called the slope-intercept equation. So hopefully this made sense. Again, if you're struggling, I always encourage you to go back, rewatch the parts you're confused about, and as always, please reach out. Thank you.